10th graders that quickly. But if my 9th graders who are already at 43%, they're already at 43% on the second interim. They're taking the third interim next week while the 10th graders are testing anyway. If my 9th graders can reach 50%, I'll bring everyone a treat. If you can get over 55, I'll bring everyone a homemade treat, meaning brownie, cookie, that's my kind of thing. I know. So let me say that again. My 9th graders are also taking the interim next week. If they can get at least 50%, everyone will get a prize, even if you're not a freshman. My 10th graders, I would give you a prize, but I won't know your results till the summer. Although if you do what you're doing during class day, let me tell you, it's going to make me so proud. So proud. Okay, as for the bell ringer, it's a hard one, so you didn't do it. I know that. You don't like word problems. Oh my gosh. What are you going to do in real life? Good thing you have a math teacher. Okay, so A says find an expression for Trent's March bill. So I'm going to do M for money, because that makes sense to me. How much does he have to pay per month no matter what? Yeah, he has to pay 30 no matter what. Now we're just trying to figure out how many hours. If it's a daytime hour, I'm going to do D for daytime. How much does he get charged? So I'm going to do 0.50D. If it's a nighttime or a weekend hour, I'm going to do N for both. How much does he have to pay then? Okay, so it gets cheaper on nights and weekends. So this parking deck is probably for what in his life? His job. That would make the most sense. Okay, this is an unrealistic problem for us. One, because there's some typos. That should be charges. And two, do we have a lot of parking decks around here? I don't park in a parking deck every day. Where do you park in a parking deck? The mall, you do? Do you have to pay for the mall? Where else do you park in a parking deck? The hospital, but you have to pay when you leave. They're smart like that. So this is not realistic for us at the moment. It could be if we lived in a state that didn't really have people drive that much. Moving on. Okay, so part B says find the cost if Trent has 12 hours of nights and weekends. So where am I supposed to plug in that 12? Well, that would make sense because it was for nights and weekends. But I need to have an exact amount to charge Trent. I need to say, Trent, you owe me $55. I need a number to tell Trent. And right now, if I plug everything in the way I have it, I'm not going to have a set number because I don't know what to plug in for D. I need to figure out what to plug in for D. So how many daytime hours?
12.
Oh, it says 12 was nights and weekends.
Oh, yeah.
How did you figure that out, Toby?
Since it's going to total of 47 hours, you take the 12 hours and you put on maximum and you subtract it from 47 total.
That's perfect. Okay, so it's 47 total hours. It tells you he spent 47 hours in March. We're trying to figure out his March bill. He spent 47 hours in March. We know 12 of those hours were for nights and weekends, which means 35 of those hours were for daytime. If you put all that in your calculator, I think you get that's 1750. So 4750 plus 3, 5150. Someone type it in. Confirm that. My math is off today. Yes, no, somebody with a calculator. Yes? 50.5?
That's what I got too. 50.
That would make sense. That would make sense. Okay, good. That's the bell ringer, and you've already partially tuned out. Terrific. Yay, there's a test on Friday on this regardless. We need to do translations first. We're going to do rotation second. Translations are the easiest. In my mind, reflections were the hardest. Okay, so yesterday we did reflections, and there was a line of reflection We had some homework problems you do not have to turn in today. If you want to go ahead and turn it in, that'd be awesome. Reflections are the hardest. Translations are the easiest. Rotations are the medium, but they're the most messed up. That's where most people make their mistake. Most people don't make a mistake on translations. So a translation is a transformation that moves all points of a figure the same distance in the same direction. So 4 to the left, 2 up. And we're going to use a translation vector to describe the distance and the direction of the translation. I know you've not heard of a vector before. It's something you'll discuss in later math classes. All you really need to know is instead of an ordered pair with parentheses, we're going to do ordered pair with these brackets that look like arrows. So for instance, 1, 2 is still going to read like a normal ordered pair. 1 would mean 1 to the right. The 2 would mean 2 up. If it was a negative 2, it would mean 2 down. If it was a negative 1, it would mean 1 left. It still reads like a normal ordered pair. It's telling us how to pick up the shape and move it. Okay, what is the translation vector on our very first example? What is the translation vector on our very first example? So I need to know how to write it. Bless you. Okay, someone last period said 2, 4. That would be wrong because that 4 would mean up 4. It needs to be a negative 4 because it specifically says down 4. Are there any questions about how I wrote that translation vector? Okay, well, of course, I need to plot all those points for my shape. So A is at 1, 2. B is at 1, 4. C is at negative 3, 4. And D is at negative 3, 2. Now, I don't think I was very specific yesterday. This first image, because it was there first, is called the pre-image. We do something to it, and the resulting image is called image. We have the pre-image and the image. Do you need to know that from me? No. Is that vocab term used on a standardized test? Yes. Okay, what kind of shape do we have? So it's a super easy shape for this first one. So if it says 2 right and 4 down, I'm going to pick up D because I like dogs. Move it 2 right, 4 down, 1, 2, 3, 4. And there's D prime. And now if Katie's not listening, she can continue this counting streak of moving over 2, down 4. But if she's paying attention to the fact that it's a rectangle, once she can put 1 in the right slot, she can put all the others in the right slot. 1, 2, 3, 4. 1, 2, 3, 4 would be where I want it to be. 1, 2, 3, 4. 2, 3, 4. My colors just aren't showing up well today. Don't know why they did yesterday and not today. Strange. Okay, so if Katie wants to, she can pick up and move each point right 2, down 4. But if it's an easy shape like this rectangle, once she knows one point, she can kind of draw the whole shape again. Are there any questions about this one? Then look at the next one. Well, they talk about translations in the coordinate plane. They explain that what we're really doing is that we're adding our translation vector to the x and y coordinates. So, for instance, if we wanted to know the coordinates of A prime, we would add 1 plus 2, get 3. 2 minus 4, negative 2. B prime, for instance, would be 1 plus 2, which is 3. 4 minus 4 is 0. And if you actually look over at our shape, 3, negative 2, hey, that's where we already put A prime. 3, 0, hey, that's where we already put B prime. So if you're wanting to check yourself and actually calculate the coordinate points, you can, because they should be the same as where we already plotted A, B, C, and D. Okay, so go to example 2. What is the translation vector on example 2? I'm about to bust them up. I'm over it. -3, 2. What does the -3 mean? Yes. Bless you. Thank you for tolerating me today. Left 3. What would the 2 mean? Up 2. Okay, is this an easy shape? What kind of shape is it? Yeah, but it's not as easy to count. So I'm actually going to physically have to count left 3 and up 2. So over 1, 2, 3, up 1, 2. There's G prime. Over 1, 2, 3, up 2. There's V prime. Over 1, 2, 3, up 1, 2. There's T prime. Okay, if Grant suddenly had a rectangle or any other shape besides a triangle, clearly he went wrong. If his triangle changed size, he went wrong as well. It shouldn't rotate. It should literally be moved left, right, up, down. It's easy to see when someone's done a translation wrong. Okay, if you've already got that done, go ahead and plot the 5 points for our pentagon. Okay, so there's my pentagon for the last example. What is the translation vector? So what does that mean? I heard down 5, is that correct? What should it be? Left 5, and then what's the -1? Okay, so left 5, down 1. 1, 2, 3, 4, 5, down 1. The more points there are, the more annoying it gets. I'm with you on that. Okay, is there anyone who's having any trouble with any of these translations? If you flip to the back, you can see the ones that are for you. I'm actually going to give you about 5 minutes to work on it now, and then otherwise it's going to be on your time. The issue is that they wrote the translation vector weird. -3, 0 is the vector for the first one. 0, 4 is the vector for the second. They just didn't put it in the notation that we're using if you want to fix that. To me, the back page looks like Tetris, so I need you to take the Tetris shape and move it to its new spot. You got 5 minutes, and I'm talking about whatever else I'm talking about. Rotations. So we're on our second set of notes because, let's face it, translations are so easy we can't just spend the whole day on those. We need to talk about rotations. Rotations are also easy, but they're the most frequently messed up. Here's why. Okay, let's start at the beginning. Okay, when we did reflections, we had to know a specific line. What was that line called? Yeah, it's called the line of reflection. Thank you, Nia. For this, there's a specific point that we spin things around. So kind of like that clock you stare at all day spins around that center point. That center point that we spin around is the center of rotation. The good news is we don't actually have to calculate that. But the top of the notes, the blank is center of rotation. What happens when you rotate something? It spins. We're turning it around. If you spin something 180 degrees, how does it spin? Is that all the way back around? No. It's halfway, right? So if I turn 360 degrees, yeah, I'm spinning in my class today. If I turn 360 degrees, I flip all the way around, yes? If I'm going 180 degrees, when do I stop? Right here? Right here. So notice you used to see my front, now you see my back. Agreed? Okay. So we need to do the same thing with all these ordered pairs. In order to do that, so yes, this common's been skipping around. I want to go to the 180 degree example. Which one's the 180 degree example? So I need to go to that one. In order to go 180 degrees, you need to flip all the way, well, not all the way around, halfway around. So all your ordered pairs change. They all change signs. So A prime would be what? If we're changing everyone's sign, what would A prime become? 3 negative 5. What would B prime be? There's no that. I've argued that before. Yes. What would C prime be? We're changing everyone's sign. Literally changing everyone's sign. Okay, well, what's annoying with this example the most is that they gave us a coordinate plane that counts by 2, so it's really hard to graph all our points. So A is negative 3, that's me halfway between 2 and 3. Negative 3, 5. B is 0, 2. C is negative 5, 1. And it's terribly annoying to count like that. So we've got our original. Now we need to plot our new image. So A prime is 3, negative 5. B prime is 0, negative 2. C prime is 5, negative 1. Okay, and this sounds funny because my example didn't really do it well. But I like to think of like a turtle. So that to me kind of looks like a turtle shell. The turtle was right side up. He was fine. Now he's flipped over. He's on top of his shell. It looks like the turtle flipped. 180 degrees looks like your shape literally fell over. It flipped. Fell over. Like the turtle. He was standing up. He was walking. Life was great. Those are his feet. And then suddenly, he's belly side up. Poor turtle. He must be dead. Okay, does anyone have any problems with 180 degrees? Then if you flip on the back, tell me which problems are the 180 degree problems. 4 and 5. So in 4 and 5, you're literally going to change all the coordinates. So instead of negative 4, 3, you have 4, negative 3. Okay, are there any questions on 180? Okay, flip to the front. Most people don't mess up 180. So again, the issue is that we have a test on Friday, and you don't get to use your notes. So at some point, this has to go in your brain. So are you going to remember for 180, you literally change everybody's sign because that turtle is going belly side up. Sawyer's nodding yes. Maybe for that one. But the 90 and the 270 is where everyone makes all their mistakes. So for 90, we're going to change the y's and flip the coordinates. For 270, we're going to change the x and flip the coordinates. And if you're reading the very top chart, that's what it explains as well. Because when it says multiply by negative 1, that's the same thing as just changing the sign. Bless you. Okay, the reason 90 and 270 are an issue is because we're trying to decide, is Miss Compton flipping this way and facing that wall, or is she flipping this way and facing that wall? I know that's really silly, but that's the truth, and that's where the issue lies. Okay, so it says for 90, we need to change the y's and flip the coordinates. So I'm going to just own my notes already. Well, let me plot those points first. So F is at 7, 7. G is at 9, 2. H is at 3, 2. I is at 5, 7. I know I've graphed it right because I got what looks like a trapezoid. And it says trapezoid. Okay, so to figure out my new guy, I need to change my y's. And I need to flip all the ordered pairs around. So, for instance, that needs to be a -7, a -2, a -2, a -7. And I need to flip their order. So F prime is -7, 7. G prime is -2, 9. What is H prime? What is I prime?
-7.
Perfect. So we need to graph all those points for our image. -7, 7. G prime, -2, 9. -2, 3. I, -7, 5. Thank you. Well, you're going to think I'm crazy because I turned every shape into a turtle right now. But our original was this turtle. He was flat, everything was good. And then when he went 90 degrees, just like if I go 90 degrees, backwards is hard. If I go 90 degrees, I end up on my side. So obviously if we were going to graph the same shape but he's supposed to go 270, he would still end up on his side. That's an ugly trapezoid. He would still end up on his side. It would just be his other side. So you can see why we have some issues with this. Okay, so look at the back. Which ones are 90? 1 is 90. 3 is 90. And that's it. So we have 2 of each on the back, basically. So 1 and 3, you need to, well, you got a little work to do. You actually have to figure out the ordered pair. For instance, this one's 2, -1. But you have to take that ordered pair, you have to change the sign of the y, and you then flip it. So my new point would be 1, 2. Because we changed the sign of the y, and we flip it to figure out the new one. Are there any questions about the 90s? Okay, bless you. Then let's go to the 270s, but I swear to you, how you will... If you're going to make a mistake, this is where it's going to happen. So on 270, it's very similar. Let me graph first before I go crazy. 4, 7. 6, 6. Sort of devilish. 3, -2. 1, -1. I know it says parallelogram, but I've made it look more like a rectangle, and that's fine. Okay, so we have this parallelogram, but we need to flip it 270 degrees. So right now I'm going to pretend the turtle feet are down here. For 270, I need for the turtle feet to end up on the left side. Okay, it says I'm supposed to change the x and flip the coordinates. So if I change all the x's, it would be a -4, a -6, a -3, a -1. And then when I flip the coordinates, what would p prime be? What would q prime be? Okay. So again, notice all we're ever doing is either flipping people or changing their signs. 6, 6, it stayed 6, 6. It's just who was negative. It never became 8, 6, 7, 6, anything besides 6, 6. Okay, so we got to plot these points. 7, -4. 6, -6. -2, -3. That does not look right. I did -7 instead of 7, -4. 7, -4. Awesome. So again, I still have I plotted a point wrong. -1, 1 was there. That's what went wrong. That's the ugliest end I've ever done. If I had white out, I would fix it. Danny, is yours prettier? Someone have a prettier one? Thanks. His is prettier because he didn't use marker. Note to self, didn't use marker in math class. Do you mind if I draw on it? Okay, so again, if we pretend that this is a turtle still, his feet were on RS. He didn't label his points, bless our hearts. 7, -4 was P prime. This is Q prime. S prime, R prime, thank you. So our feet were on RS before. If they're still on RS, then everything ended up the way we wanted. The feet ended up towards the left. I seriously put feet on all my shapes to make sure 90 and 270 twist the way I want them to twist. 90, the feet end up on the right. 270, the feet end up on the left. 90, the feet end up on the right of my turtle. 270, the feet always end up on the left. If you draw feet on your shape and keep track of the feet, then you can know whether or not you made a mistake or not. And then I would feel sorry for you because you're trying to think like me. Okay, are there any questions about any of these? We're flipping people. We're changing signs. We got to keep it straight because that's where you can't use your next. Okay, I'm done talking to you. I swear you have enough work to kill somebody. So.